Hello everyone, my name is Dr. Susan Kafle and I'm back with the part 3 of the video series Localizing the Strokes, and in this video I'll be discussing about the lateral and medial Pontine syndromes. If you have not watched my previous videos of this series, then I highly recommend that you do that, because in order to understand this, first you need to understand the basics. As I've already told in my previous video, the whole of the brainstem can be divided into the right and left halves, and we can divide the brainstem into three parts by these horizontal lines. The topmost is the midbrain, the middle one is the pons, and the lower one is the medulla. And each half we can divide into the medial and the lateral halves. And in pons we have the cranial nerves 5, 6, 7, and 8 following the rule of 4s, and 6 cranial nerve number 6, since it is a prime number of 12, so it is lying towards the center, whereas cranial nerves 5, 7, and 8 are lying on the lateral sides. Besides this, we have the medial and the inferior cerebellar peduncles on the lateral side. And then we have the tracts. On the medial side, we have an ascending tract that is called the dorsal column medial lemniscal pathway, and a descending tract called the corticospinal tract. Apart from this, on the lateral side, we have the spinothalamic tract, that is the ascending tract, and the descending tract is the sympathetic fibers. Now, in case of pons, in the rostral region of the pons, or towards the upper side, we have another descending tract, which is the corticobulbar tract. This will be relevant when we are discussing the medial Pontine syndrome. Now I want to discuss what are the corticobulbar tracts and why are they spared in the medial medullary syndrome. We know that the corticospinal tracts originate in the cortex, pass from this internal capsule, descend downwards in the caudal medulla, they decussate to the other side. So this is the corticospinal tract. Just like the corticospinal tract, for the cranial nerves that are motor, like motor cranial nerves, we have another tract similar to the corticospinal tract. This also passes through the internal capsule, but corticospinal tract passes through the posterior limb of the internal capsule, whereas the corticobulbar tracts, they mainly pass through the genu of the internal capsule. So they descend downwards the corticobulbar tracts and they supply to different motor nerves, cranial nerves in the brainstem. So what are the different motor cranial nerves? I like to remember these things with this diagram. This is like a signature. So the topmost are the sensory nerves, this is the motor nerve, and this is both. The lowermost is the sensory as well as the motor. So we start naming the nerves. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So sensory nerves, they don't have the corticobulbar tracts because they are sensory. As I said, corticobulbar tracts, the term this applies only to the motor nerves. In case of cranial nerves number 3, 4, and 6, these don't have corticobulbar tracts either because they are controlled by something else, which I'll discuss in the next slide. Now we have cranial number 5, 7, 9, 10, 11, and 12. So out of these 6 cranial nerves, the 11th does not have a corticobulbar tract. So cranial nerves 5, 7, 9, 10, and 12, they have their supply from the cortex, and that is the corticobulbar tract. It's like the oculomotor neuron of the cranial nerves that I just mentioned. So the definition is the cortical motor pathway that descends to cranial nerve motor nuclei in the brainstem, controlling the voluntary head, face, and neck movements. In this table, I have highlighted some key differences between the corticospinal and the corticobulbar tracts. So both are originating in the motor cortex and both are descending downwards through the internal capsule. This descends through the posterior limb, whereas corticobulbar descends through the genu. All right, and corticospinal tracts are going all the way down to the spinal cord, whereas corticobulbar tract, they terminate at the level of the cranial nerve motor nuclei. Most of the corticospinal tract, as it descends, as they descend, they decussate at the caudal brainstem, whereas the corticobulbar tracts, 50% of them cross to the other side, whereas 50% remain on the same side. And the function of the corticospinal tract is voluntary limb and trunk movement, whereas the cortical bulbar tract, uh, it controls the head, face, and neck movements. So like I mentioned before, the third, fourth, sixth, and 11th cranial nerves in the brainstem do not have corticobulbar supply because they are controlled by some other structures. Like 3, 4, and 6, they are controlled by the medial longitudinal fasciculus and the gaze centers. We'll discuss about these in the upcoming videos. And the 11th cranial nerve, it is supplied by an upper motor neuron from the cortex, which is not fully a corticospinal tract or not a corticobulbar tract. So this is like a hybrid. So we have the corticobulbar supply to cranial nerves number 5, 7, 9, 10, and 12. These 5 nerves. So now let's talk about the lateral Pontine syndrome. As we can see in this diagram, the lateral part of the pons lateral part is supplied by the anterior inferior cerebellar artery. So we have the involvement of this artery in case of lateral Pontine syndrome. In the lateral pons, we have cranial nerves nuclei number 5, 7, 8 cochlear, but actually the cochlear nuclei, it lies slightly below, so it rather than cochlear nuclei being involved, we have the involvement of labyrinthine artery, and the vestibular part of the 8th cranial nerve is involved. Also we have the involvement of middle and inferior cerebellar peduncles and these two tracts. Different manifestations of lateral Pontine syndrome. As you can see, there is involvement of 5th cranial nerve, so there will be ipsilateral loss of pain and temperature on the face. There is involvement of the 7th cranial nerve or the facial nerve, because of which there is paralysis of the upper and lower face and loss of taste from the anterior 2/3 of the tongue. Remember, so whenever there is lower motor neuron lesion of the facial nerve, there will be involvement of both the upper and lower face. This is in contrast to the upper motor neuron lesion of the facial nerve, where you have involvement only of the lower face. And then we have the involvement of labyrinthine artery. You can also remember the cochlear nuclei, but actually it is the labyrinthine artery. So if this is involved, there is ipsilateral sensory neuronal hearing loss and vertigo. Then we have involvement of the vestibular part of the 8th cranial nerve, because of which there is vertigo, nystagmus, nausea, vomiting, ataxia, and impaired vestibulo-ocular reflex. Then we have involvement of the ascending tract, that is the spinothalamic tract, because of which there is contralateral loss of pain and temperature in the body. The descending tract or the sympathetic fibers, because of which there is ipsilateral Horner syndrome. And then we have these two peduncles. Remember, I told in the last video to think of the syndromes in relation to the cranial nerve nuclei, the tracts, and the peduncles. So when the peduncles are involved, there will be ipsilateral ataxia and dysmetria. So as you see here, in the body we are having contralateral symptoms, whereas in the face we are having ipsilateral symptoms. So the brainstem lesions, they are known to cause the crossed hemiplasia. Like in the face there will be the weakness on one side, whereas in the body there will be weakness on the other side. So this is called crossed hemiplasia. Now let's talk about the medial Pontine syndrome. In medial Pontine syndrome, we have the involvement of the basilar artery. To be specific, the paramedian branches, these branches of the basilar artery, are involved in the medial Pontine syndrome. So what are the structures that are involved in the medial Pontine syndrome? So we remove the structures from the lateral part. So we are left with the 6th cranial nerve. 6th cranial nerve, these two tracts. The ascending one is the dorsal column medial lemniscal pathway. The descending one is the corticospinal tract. And apart from this, as I already said before, in the upper part of the pons, corticobulbar tract is descending. So if there is a lesion of the upper pons, we also have involvement of the corticobulbar tract. Now, what are the manifestations of medial Pontine syndrome? So because of the involvement of cranial nerve nuclei number 6, we have ipsilateral loss of horizontal eye movement. So now there is involvement of the dorsal column medial lemniscal pathway. So there is contralateral loss of fine touch, pressure, proprioception and vibration. And there is a descending tract, that is the corticospinal tract, that is involved. So there is contralateral hemiparesis. And if corticobulbar tract is involved, there is loss of voluntary face, mouth and tongue movements. All right. Now there is another structure that lies in the pons, extends from the upper medulla upwards till the lower midbrain. So that is the reticular activating system. The reticular activating system may be involved or may not be involved in medial Pontine syndromes, especially if there is a large basilar artery stroke rather than the stroke in the paramedian branches of the basilar artery. RAS may be involved. Now the RAS is responsible for the consciousness, the arousal. So if we have a medial Pontine syndrome or a large basilar artery stroke involving corticobulbar corticospinal tracts, leading to the paralysis, complete paralysis of bilateral side, as we know, the basilar artery. Rather, if the paramedian branches are involved, then the symptoms may be on the one side. But if this whole basilar artery is involved, then the symptoms can manifest on the both sides. So that will lead to bilateral hemiplegia, bilateral, a weakness of the face, head and face, head and neck. But RAS is spared, then the consciousness will be preserved. So that is called locked-in syndrome. So what I was talking about is the basilar artery is running from the upper medulla till the lower midbrain. So involvement of the basilar artery can lead to ischemia of either the upper medulla, pons or the midbrain. This is a very large artery, so yeah. Now there are 3 different variants of medial Pontine syndrome. Actually, in medial Pontine syndrome, the classic features that we should have is involvement of the 6th cranial nerve nuclei, then the dorsal column medial lemniscal pathway, and then the corticospinal tract. But in some of its variants, not all of these tracts might be involved. So I prefer remembering these variants with the mnemonic raise, mill, factory. So we begin by remembering the classic features: involvement of corticospinal, cranial nerve 6 nuclei and dorsal column medial lemniscal pathway. So in RAISE stand for Raymond syndrome. In Raymond syndrome we cut this dorsal column medial lemniscal pathway, and hence we only have involvement of corticospinal tract and cranial nerve 6 nuclei. Then M stands for Miller-Gubler syndrome, where now after in this corticospinal tract and cranial nerve number 6 we add cranial nerve number 7, and in factory F stands for Foville syndrome. In the structures that I just mentioned, corticospinal tract plus cranial nerve 6 plus cranial nerve 7 plus minus dorsal column medial lemniscal pathway. So these are the different variants which might be asked in the exams, but this is not super high yield. So that's it for this video, guys. I hope you enjoyed it. Stay tuned for more. I'll be back with the midbrain syndromes in the next presentation. Thank you.